Right. Question 3. Solve each linear system by graphing. But we did talk about it at the end of last lesson. What does it mean to solve a system of equations?
Find something that's equivalent to x, or you will give them one.
It's like to be able to find what you can substitute.
I need more detail. I went through lots of detail at the end of last lesson. Glad it was worthwhile. No? You don't remember? I think I put this... put that diagram on the board. That's what we were talking about. So 2 lines intersect is what we're looking for. But what does it, when I find that point, what does that ultimately mean, Dave?
Oh, they share equation?
Yeah.
They share.
And what does that mean by, well, the fact that they share a point means something.
The gradient's the same.
No, definitely not.
Oh, wait.
Yeah? Yes, but the fact that they share it means what? What does it mean to be equal to each other? What values are the same?
The y and
The x and y.
The value of x will be the same in both equations.
So we'll go fries over.
I'm being picky here because this is a fundamental, this is the thing, if we don't understand, we have a bit of a, I know what to do, I don't really know why I'm doing it. That's why I'm focusing on this. I often find there is a big disconnect between solving equations and what that result actually means. All right? So, what I've got on the board is a kind of rough sketch of potentially 2 lines, but what are lines?
Oh,
Infinite number of points. Now, what did I say by writing those 2 things up?
If you put the same value of x in each one, they'll meet.
What does it mean they'll meet?
Like, that's the point they meet at.
But what does that mean?
you get the same point.
You get the same what? Don't say point.
Great.
They definitely can't be the same gradient. Why?
They're all
So
like
then
nearly
they
opposite.
would never be same
They
y.
are the same gradient. They would always.
So either they would be the same line, therefore,
They never.
if they're the same line, they always meet. They're the same line. If they're the same gradient and not the same line, they are
Parallel.
parallel, and there will never be a solution. This is something we will eventually talk about. So the fact that they do cross means they share a point, which means the gradient must be different, must be, all right? What does it mean? And we were so close, all right? Because remember, what is a line? An infinite number of points. Where do those points come from?
Data. Coordinates.
The points don't come from coordinates. The points represent the coordinates. They're the same thing. Where do those coordinates come
Oh,
from?
the x and y axis.
Well, the x and y axis are used to draw the point.
The x and y values.
Okay, so how do I figure out the x and y? Well, which one do you choose?
Doesn't matter.
You substitute a number in for x.
Okay, you substitute a number in for x. The function, the equation, will tell you which value of y goes with the value of x, right? How many possibilities are there? So if I put a 3 in for x, how many possible options for y are there? One. Only one. They go as a pair, right? Can we do this? If x is -1, y has to be -1. So if I put a value of x in, I get a value of y out, yeah? I could leave that as just a table of numbers. What do we do instead of that? Remember the boards? We could have a table of numbers. We can turn it into, well, we've got an equation now into a table of numbers. We could do a graph. What's different about a graph compared to a table of numbers?
It shows you what's in between those.
A graph, perfect answer. A graph is a visual representation of the table. You can see the behaviour of the numbers that go together. All right? Does that make sense? So what does it mean if two lines cross? Well, it means if I put an x value into one equation and I put the same x value into a different equation, both equations will give me the same y value out at the end, right? Therefore, the x and the y values are the same. Will that always happen? Will I always have at least one time where if I put an x value into two different equations, I get the same answer out?
Yeah.
We've already decided no. How do I know no? Because sometimes lines are parallel, which means if I put an x value into both, I will always get a different y value, always. All right? So, if you can remember that the graphs are not anything special other than a visual representation of the numbers, it makes sense that, okay, how do I find the point where the x value goes in and the y value is the same? Well, if I look at the graphs, I can see where they cross, right? And then I can find it. Why would I want to do that? Well, we do have situations in real world scenarios where finding where two lines cross tells us something. Does anyone have any ideas at the moment? It doesn't matter if you don't.
If you're building with two roads, you need to know where the intersection would be.
Two rows.
Like if you're building.
Maybe if they're perfectly straight roads and you've got a coordinate system for where the roads go potentially. I'm thinking more of I've got some data and I've got functions to do it. We will look at things like this, right? We did talk about it with our linear functions, with our initial condition and our gradient. Remember, we did talk about mobile phone charging, did we?
Yeah,
Yeah. What did the gradient represent?
the phone's battery. Wait, no.
The speed at which the phone can charge.
Exactly how quickly it charges, yeah?
And the initial condition.
And the initial condition
The
is
phone's battery.
where it was at the time, yeah? It could have been 0, it could have been at 10. Now, if two lines are not parallel, what does it mean about the charging rates of the two phones?
They're different.
They're different. What does it mean then if they cross?
At one point they'll be at the same speed.
No.
Say it again.
At one point they have the same speed.
No, they don't have the same speed because the gradient represents the speed of charging. They have the same battery percentage at the same time. So if we find that point, we'll know when. So one line will be going up less than the other, yeah? So for this situation to happen, the one that charges quicker needs to start at a lower level, right? Anyway, I won't talk too much about that because we'll get into that. That's what this unit is all about, applying this to real world. You with us, Sammy? You good? Folks? Right. So what we're going to do is we need to find that crossing point because it can be very useful to us. But we've got several ways. We've got graphing, which is the easiest way because we can use technology. We're also going to do it by hand, but we're also going to do it in algebraic ways. We've got two algebraic ways.
I
We've
found
got
the point.
elimination and substitution. So the graphing method, let's say I want to do this one. I think you've already know that's why we've been using GeoGebra, right? So if we do the first one, 2x minus 6, x plus 3, what was it? Y equals 2x plus 6. Is that right? Yeah, 2x minus 6 and x plus 3. So if we put that in, 2x minus 6 and y equals x plus 3.
They meet at 9 and 12.
Okay. Oh, mine's broken. Why doesn't it cross?
You're not scrolled up.
I'm not scrolling it. Just need to go. Yeah. Two lines cross, look. You can see if I zoom out. The red one goes up faster and the blue one goes up slower. Does that make sense? Based on the equations? How would I know that's going to happen anyway? Miles?
You said that which one goes up faster?
The steeper, the red one. 2x minus, it might not be red on yours, so 2x minus 6 goes up faster than x plus 3. How do I know that that was going to happen?
It goes up 2 for every x. The y goes up 2.
Matthew, what were you going to say?
I was gonna say that the 2 is the speed of which the battery travels.
Yeah.
And there's 2 x.
So this one's going up 2% every minute, for instance, but this one's only going up 1. All right, so this one is definitely going to go up quicker, right? This one starts at -6. Doesn't make a lot of sense with battery charging, but we get the idea. This one starts at +3. So the blue one starts higher but goes up slower. The red one starts lower but goes up quicker. Therefore, it makes perfect sense that they will eventually meet, right? Where do they meet? They meet in the middle. If we click,
9.
it tells us 9 and 12. Now, what do I do with that information? So, what you are going to do is you're going to write out the solutions. Where's my pen? So, when we solve y equals 2x minus 6, y equals x plus 3, we get our solution. The solution is 9, 12. How do I interpret that?
X, I don't know.
X equals
9.
9. Y must equal
12.
12. Okay. Now we can do this for the first few. Let's do a check. How can I check?
Substitute the x for 9.
Substitute it in. Let's do it. So let's substitute x is 9 into this and just check I get the answer 12. Right? So y equals 2 times 9 minus
It
6.
works.
So y equals 18 minus 6,
Which is
y
12.
equals 12. That's good. What about the other one then? Right? We've got y equals 9 plus 3. Y equals 12 is also good. They both give me the right thing. Right? It is important when we do this, more so when we do it algebraically than when we do it graphing, that we do that check because we might have made a mistake. I mean, graphing method on computer, the only real mistake is you typing it in wrong, right? But it can happen. So if we go back to the question and put the answer in, we might go, oh, why isn't that working? Oh, I did the wrong equation on the computer. If you only check one of them, you will find that you made one mistake and you didn't check the right one, or the one that you made the mistake in, and you'll go, oh, it works for one of them, it must work for both, and it doesn't necessarily work that way. Okay? Do you understand? Okay, over to you then. You can do the rest.